work with linear inequalities, but this time we're starting with inequalities that are not in slope-intercept form. Okay, so let me show you what I mean. On this side, if you look at this inequality, it's not in the format where we can easily recognize the slope or the y-intercept. So we're going to have to rewrite this, isolate y on the left side, and then have it written in this format so I know who the slope is and who the y-intercept is. So we're going to have to work a little bit and rearrange that inequality. But first, remember that inequality table, reference table I showed you last time, so I put it up again. So when the inequality sign is greater than or less than, without the equal sign at the bottom, we're going to use a dashed line because points on that line are not part of our solution. And then when it's a greater than or equal or less than or equal, we're going to use a solid line because points on that line are part of our solution. So let's start by rewriting an inequality. So the first thing we want to do is subtract 4x from both sides, right? We're going to do minus 4x from this side, and I'm going to put a line here in the middle. So that stresses us that we have a left side and a right side to this inequality. So I'm going to subtract minus 4x and minus 4x on this side. The plus 4x and minus 4x goes away because it becomes 0. 2y is the only thing left on the left side, so I'll write 2y. Less than, and these two are not like terms, so I can't subtract them, so let me just write that 8 minus 4x is the same thing as negative 4x plus 8. And then now to get rid of the coefficient of 2, because it's being multiplied, we're going to use the inverse operation, which is division. So we're going to divide this by 2. And here is the trick. Remember, on the other side, when I divide the left side by 2, I must divide all the terms on the right side by 2. So I'm going to put a little 2 under the negative 4 and a little 2 under the 8. Right? So everybody gets divided by 2. 2 divided by 2 is 1, and 1 times y is just y. Less than, and then careful here, negative 4 divided by 2 is negative 2x. And then positive 8 divided by 2 is plus 4. So now it's in the format, and I can easily recognize that negative 2 is my slope. Right, so I'm going to write that my slope is negative 2, and I'm going to write it as negative 2 over 1. So we know that the difference in y units is 2, right, going up and down. And the difference in between x units is 1 going left and right, and our y-intercept is 4. So let's start with our y-intercept. Let me change colors here. I'm going to go to positive 4. So we have a line that's going to come through 4. Now, my slope is negative, so we know that our line is going to go down from left to right. So that's what my line looks like. So up and down, I'm going to count 2. So let's go up 2, and then I'm going to go left 1, right? And if I go down, I'm going to go down 2, 1, 2, and right 1. And let me get a few points here. So down 2, right 1, down 2, right 1. You don't need as many points, but I'm just putting it there because we can. So now, and the symbol is a less than sign right here, less than sign. It doesn't have the equal sign, so we're going to use a dashed line. So let me figure out what dashed line here is. There it is. Let's connect the points. So that's the line. Y is less than negative 2x plus 4. And now the solution, or the points that satisfy this inequality, are either going to be above the line or below the line. So we need a test point. So we're going to use a test point, right? And the easiest test point when available is 0, 0. And 0, 0 is available because it's not on the line. So let's try 0, 0. If 0, 0 makes this inequality true, then we want to shade under the line. If 0, 0 does not make this inequality true, we're going to shade above the line. Okay, so let's rewrite the inequality. Y is less than negative 2x plus 4. Let's replace y and x with 0 and 0. So y is 0. Less than negative 2 times 0 plus 4. 0 is less, negative 2 times 0 is 0 plus 4. And 0 is less than 4. Is 0 less than 4? It is. So that is telling us that every point, and 0, 0 is below that line, so 0, 0, and every point under this line makes that inequality true. Okay, so remember, we shade, and hopefully you'll do a better job shading than me, right? And there we go. So any point, and I'll write a big S over here, any point in this area makes that inequality true. So I am going to just take one more point, I'm going to pick one point right here, this point right here, and that's the point -5, 3, and I'm going to use it in the inequality -2x plus 4, right, just to show you that another point. So I'm picking out another point to prove to you that it also satisfied the inequality. So remember, first coordinate is x, the second is y, so we get 3 less than -2 times -5 plus 4. 3 less than -2 times -5 is +10 plus 4. And 3 is less than 14, which is a true statement. So notice that this point also worked to satisfy my inequality. And that's it. So the trick today is to rewrite the inequality, which is not in slope-intercept form. Okay, write it into slope-intercept form, and then graph as we did the previous lesson. Okay, so what I'd like you to do is try the next problem. Okay, press pause on your video, give it a try, and then come back and see how you did. All right, so again, first thing we do is we're going to rewrite this inequality so that it looks like this. Y is greater than or equal to, or less than or equal to, depending on what we do over here. So what's the first thing we do? The first thing we want to do is add 2x to both sides. So plus 2x on this side and plus 2x on this side. So I'm going to make a little line in the middle, right, just to remind me that there's two sides to that inequality. So if I add -2x plus 2x, I get 0. Right, so that goes away. And the only thing left over on the left side is 3y. So I'll write 3y. Greater than or equal to, and then 6 plus 2x can't be added because they're not like terms. So I'm going to write that as 2x plus 6. Next step, notice that we have to get rid of the coefficient 3. And 3 is multiplying that y, so we're going to use the inverse operation, which is division. So we're going to divide, and let me change colors over here. Divide that by 3, and divide every term on the right side by 3 as well. So divide that by 3, divide that by 3. Change colors one more time. 3 divided by 3 is 1, and 1 times y, which is what I wanted. Y is greater or equal to. And then 2/3 x, we're just going to leave it as 2/3 x. And then +6 divided by 3 is 2. So now it's in the format that you and I like, where we can easily tell that this 2/3 is my slope, and the 2 is my y-intercept. In this case, we have a slope that's positive, so this time our line's going to go up from left to right. Right, 2 is my change in y units. So up and down, I want you to count 2. And then 3 is my change in x units. So left and right, you're going to count 3. So what's my y-intercept? It's 2. So we have a line that's coming through 2. And let's get a few more points on the line. So 2/3. So 2 up and 3 to the right. 1, 2, 3. 2 up and 3 to the right. 2, 3. Let's get a few points on the other side. 2 down and 3 left. 2 down and 3 left. So that gives us. And now look at our sign is greater than or equal to. So when it's greater than or equal to, we use a solid line because points on that line satisfy our inequality. So let's connect. Just adjust the line just a little bit. There we go. So we now want to know if we're going to shade above that line or below the line. It's to see if which is the area that satisfy the inequality. So let's take a test point, and we can pick 0, 0. So let's use the test point 0, 0 and see if 0, 0 satisfied the inequality. So let me write that inequality. The inequality is y is greater or equal to 2/3 times x plus 2. We're going to replace 0 for y and 0 for x. We get 0 greater or equal to 2/3 times 0 plus 2. And then we get 0 is greater or equal to 2/3 times 0 is 0. And then plus 2 is just 2. Is 0 greater or equal to 2? No, it's not. So that means that because this point 0, 0 fail, it also means that every point under the line is also going to fail. So we don't want to shade the line, the area that's under the line, but instead we want to shade the area that's above the line. And that's what I'm doing right now. So that means that every point on the line and above the line satisfied the inequality. Okay, and that's pretty much it. But I want to take the opportunity and select a point on above, and I'm just going to pick a random point. Let's pick this point right here. That point is 2 comma, that would be 2 comma 7, and I want to prove to you that that point is part of the solution. So again, let's write the inequality. Y is greater than or equal than 2/3 x plus 2. Let me change colors. So this is my x coordinate, this is my y, so we get 7 is greater than 2/3 times 2 plus 2. 7 is greater than 2/3 times 2 is 4/3 plus 2. And then 4/3, the same 4/3, by the way, it's equal to the same thing as 1 1/3. So if I add 4/3 plus 2, I get that 7 is greater than 3 1/3. Is that true? Yes, it is. Right? So that point, this point, 2 comma 7, satisfied the inequality, which also tells you that any point above our line also satisfies our inequality. Okay? That's it.